One of my favorite things to do in math is to solve word problems. They're interesting, they're different, and they open your eyes to a variety of different ways math could be used in the real world. Let's go ahead and just jump right in with an example. Floyd is an aspiring music artist. He earns $20 per hour as a music producer and $25 per hour as a sound editor. Last week, Floyd earned a total of $690 and worked 30 hours. How many hours did Floyd work as a producer and how many as an editor? So in this particular example, there are two unknowns that we have. So you're going to need to define two variables. Let's talk about our first unknown. How many hours per week Floyd worked as a producer? So we're going to say, let X be the number of hours a week Floyd worked as a producer. For our second variable, that, of course, is how many hours a week he worked as an editor. We have to use a different letter because they might not be the same thing. So we're going to define that as Y. Let Y be the number of hours per week Floyd worked as an editor. Now we need to translate the information in the sentence. First, we know that Floyd worked a total of 30 hours and earned a total of $690. Those two things have two different units, so they're going to be the result of my two different equations. I'm going to need an equation that talks about Floyd's hours, and I'm going to need an equation that talks about Floyd's money. Of course, the number of hours he worked has to be a part of the money. Okay, so let's first talk about his hours. If he worked X hours as a producer, and he worked Y hours as an editor, we are told from the problem that that totals 30. So X plus Y equals 30. Now let's go to how much he earns. I know that the money he earns as a producer is $20 per hour. So 20 times X. Then the money that he earns as an editor is $25 per hour, or 25 times Y, because we don't know the hours. And that's going to equal $690. Now I have my two equations with my two unknowns. You can solve this by substitution, by elimination, but I probably wouldn't solve it by graphing. Can you think of why not? Yeah, you're right. It's absolutely too large of numbers and might be a little too cumbersome to do by graphing. Not impossible, but you probably want to use substitution or elimination. Whenever you're deciding, make sure you pick with purpose. If you evaluate your two equations and you realize, wow, it's really easy to isolate one variable from one equation, or setting up elimination and getting two coefficients on one variable equal and opposite isn't a big deal, then make sure that you're choosing with a reason. I think that substitution would work great here, or elimination. I'm going to go ahead and use elimination, and I'm going to choose to eliminate the x's. Therefore, I'm going to multiply this top equation by negative 20. That's going to change my equation. Let's write it down here. And I'm going to have negative 20x plus a negative 20y equals, and don't forget, you also need to multiply this piece by negative 20 as well, a negative 600. Now I'm ready to add these two equations together. Remember, if you do this and something doesn't eliminate, you have an error and you need to go back and check your work. 20 plus a negative 20 is 0. 25y minus 20y leaves me with 5y. And 690 minus 600 is just plain 90. Now I can solve pretty easily using inverse operations for y. Divide both sides by 5, and I'm left with y equals 18. And that's 18 hours that he worked as an editor. Now that I know what y is, I need to go back and solve for x. I'm going to plug 18 back into the first equation because the numbers are a little bit smaller, and I can do what I want. So now I'm going to have x plus 18 equals 30. Using inverse operations, I can subtract 18 from both sides, and that leaves me with x equals 12. Now that I know x and y, I need to make sure that I write my answer as a statement. Floyd worked 12 hours as a producer and 18 hours as an editor. And there's your final answer. Let's try one more. Do you remember our distance, rate, time problems with water currents or air currents? Well, we can still do systems even with these. This one says a boat traveled 30 kilometers downstream in 3 hours and made the return trip in 5 hours. Find the speed of the boat in still water. So we've got two unknowns here. The first, of course, is going to be the speed of the boat in still water. We're going to say that that's R. But I also know that we have downstream and upstream. That means that the stream itself has a rate as well. We're going to call that B. You can pick any letters that you like for these. So you know that distance equals rate times time. Well, we have to talk about the rate in terms of downstream and upstream. There are going to be two parts for the rate there. I know that the distance is going to happen to be the same for both of them, so 30. And then let's talk about downstream first. Downstream means that the speed of the boat is being helped by the speed of the stream. We're adding those together. We need to put them in parentheses because that's going to be my total speed. And that, of course, is going to take 3 hours. So the rate times the time. For my second equation, I still have 30 kilometers, but the speed of the boat is working against the speed of the stream. So there, I need to multiply that by its time, which was longer. It took 5 hours. Now I have two equations with two unknowns. This outside value needs to distribute to everything inside. And the same thing happens here. That's going to leave me with two pretty simple equations that I can set up. That'll be 30 equals 3r plus 3b, and 30 equals 5r minus 5b. You can use substitution or elimination here. I'm going to use elimination, and I'm going to multiply this top equation by 5. I need to be fair and distribute this 5 to everything. 5 times 30, let's put this down here. 5 times 30 is 150. 5 times 3r is 15r. And 5 times 3b is a positive 15b. Now I need to multiply everything in the second equation by 3. This will get my coefficients on the b's equal but opposite. Let's put this one down here. That will get me 90 equals 15r minus 15b. Now that the coefficients on the b term are equal and opposite, I can add them together. 150 plus 90 is going to be 240. 15r plus 15r is 30r. And the b's should cancel out. If it doesn't, you know you made a slight error and you need to go back. Divide both sides by 30, and I get that the rate of the boat in still water is 8 kilometers per hour. One of the reasons I chose to eliminate the b's as well is because I knew the question was actually asking me for the rate of the boat in still water. It was asking me for r. I don't really need to go back and solve for b at this point, but if you want to, you can. And be careful. Sometimes that is something that happens. They ask you for answers to both, so always check. Okay, so we're going to do a lot more of these in class with the word problems and work on them. I think 2 examples is good enough because you've practiced this quite a bit. Don't forget, you can also have things that don't work in consistent systems or things that always work dependent systems. So just watch out for those.
Subscribe.
Good luck. Oh,
Subscribe.
and subscribe.
That was so sad. That was rude.